Okay, so you all will let me know if you can see my screen right now. Can you all see compounds?
Not yet, miss. Yes, miss, I'm seeing it now.
Wonderful. I will also record our virtual sessions just in case. Sometimes the internet tends to give problems in certain areas. There are a lot of technical problems, but it isn't to say to miss class, because not every time that recorded might be posted early o'clock, and it might be posted late, and you might not be able to do the homework in time. So it's always important to be in class, in attendance, and not rely on just the recording. Alright, because we do take the road. So first to begin, we have to understand what is the meaning of the term mixtures. Alright? And everything will be sent via the Google Classroom. So a mixture is something that is going to contain two or more substances, and that can either be an element or a compound. Now these are two terms you probably would have heard in term 1. Alright, so we have compounds and then we have elements. Alright, so an element is a pure substance that cannot be broken down into simpler substances. So elements is like standalone type of substances. So that could be anything from the periodic table. It could be aluminum, it could be gold, iodine. Those were elements that you probably would have heard. Compounds now, it have a little difference, is when you have a pure substance that is formed from two or more different types of elements. So these can be actually separated. Alright, so they consist of two or more different types of elements. So that could be something called sodium chloride, or which we know as salt. Now a mixture is when it has two or more substances, whether it be an element or a compound, which is physically combined together. Alright, and it can be separated. So each component can be separated and they share general characteristics which are the composition can vary, meaning the amount of elements and the amount of compounds that combine together. It can vary the amount. The properties are variable because its component parts keep their individual properties. So whatever element and compound would have combined together, they would have its own individual properties. Its component parts can be separated by the physical means, and we will learn those physical means to separate the mixtures. Now there are two types of mixtures that can exist. You have the homogeneous mixtures and then you have your heterogeneous mixtures. Homogeneous mixtures are uniform mixture. So it is very hard to distinguish the two elements or compounds that may be in it, right? It's hard to distinguish that. So it's uniform. Heterogeneous is non-uniform. So you could actually see separations. So sometimes they, like let's say make a smoothie and you leave it to stand, you could actually see it separated. Alright, so that is like a heterogeneous mixture. What is something that is homogeneous that you won't be able to see the different components? You can raise your hand. Anaya.
Miss, would it be like a salt and water mixture?
Salt and water, once the salt is completely dissolved in it, then it says homogeneous. Also, you could probably say things like juice. Once everything is completely dissolved and you're not seeing the particles like sugar, the sugar granules in it, it is homogeneous. Now this is important to learn as well. All solutions are homogeneous. So whatever you mix, whatever solution you mix, and once it is uniform, that's a homogeneous mixture. Alright? Heterogeneous would be things like a suspension and a colloid, and we will look at those separately. So let's start with the word solution. Solution is a homogeneous mixture of two or more substances. One substance is usually a liquid. So either you have a liquid combining with a solute. Now we have a fancy way of saying the word liquid. We refer to it as solvent. So solvent could be water, it could be milk, it could be whatever liquid which will dissolve something else. Now what is being dissolved is a solute, so that is what we refer to as a solid. Alright, so solute could be a solid. So that could be like salt, that could be sugar. And when these two completely form together or combine together, we produce what you call a homogeneous mixture. Alright, so solutions in which a solvent is water is known as an aqueous solution. That's different. You have different kinds of solutions as well. But just to take note, solute and solvent combines together to form a solution, and that is an example of a homogeneous mixture. Okay, so let's move on now to different types of solutions. So this is a table I would like you all. Now there are certain things when I send a note I would like you to take down in your book, and that will be like the definitions. So you should start off by taking down the definition of a mixture. You can also take down the definition of the homogeneous mixture and heterogeneous, definition of the solution and what it consists of, and also take down this table. So what does this table tell us? The different types of solutions. So here are some examples. So if we mix a solid and a liquid, for example seawater, seawater could be sodium chloride dissolved in water. That is a solution. Liquid and liquid. Now you could have two liquids forming a solution, that is like vinegar. Right? Everyone have vinegar in the kitchen. Most people use vinegar to wash their meats, to clean, a lot of uses, and that consists of an acid called ethanoic acid, which dissolves in water. A gas and a liquid could form soda water. Alright, so that's a different type of solution. So you get that in soft drinks. Alright, you could also get there's actually a drink, there's soda. There is something called soda water you could actually purchase. Alright. Solid and solid, well that is something like an example here is what we call bronze. Alright, so that is what in chemistry we learn it as a metal alloy. So it's like two metals that form a unique type of substance. And they use bronze when you are making tins. So tin cans contains a metal called tin, and sometimes there's copper, and when they combine together it forms bronze. And lastly, you can have two gases which is found in the air. So the air that we are breathing in, now we only taking in oxygen, but that air consists of different gases combined together. So that could be like oxygen, carbon dioxide. All of these gases are around us. Alright, so those are different types of solutions. Suspensions. By the way, any questions with solutions? No questions yet? Okay. I'm seeing a lot of introductions here. I hope you all are following so far. Now, if it is you've probably missed out what I said with what to write down, you could go back to the recording, okay? Because I'm recording this session. So after solutions comes suspension. So this is something I want you all to take down. A suspension is a heterogeneous mixture in which minute visible particles of one substance are dispersed in another substance, which is usually a liquid. So this is the one that you could actually tell the different components. They tend to separate where you might see them floating. So mud and water is an example. Powder, chalk and water, they don't uniformly dissolve into each other. Alright, oil shaken in water is also an example of a suspension. And you actually see that when you're cooking. Like if you have, like if you take some cooking oil and you put it in water, it will never mix. Dust in air is also a suspension. Sometimes when you're sweeping, you tend to see the dust particles in the air. You can actually see it. Alright, so it's not a uniform mixture. Hence, it's called a heterogeneous mixture. So you're going to take down everything here for suspension, the examples included. Up next is colloids. So this was another example of a heterogeneous mixture. So colloids is when you have minute particles of one substance are dispersed in another. So it's similar to the suspension. However, the difference is the dispersed particles is larger than those of the solution. Alright, so the dispersed particles is larger than those of a solution but smaller than those of a suspension. So it's like an in-betweener. Right, so yeah, the particles that would have been in the suspension is larger, but the particles that is found in the colloid is smaller, but it is larger than the ones found in solution. So if you're thinking of size, you would think of solution, colloid in the middle, and then suspension. This is a table to take down as well because it's showing you different types of colloids. Gel. A lot of people use gel in their hair, and that consists of gelatin and jelly, like petroleum jelly. So the solid particles disperse in a liquid. Emulsion. That is when liquid droplets disperse in a liquid. So that could be like mayo, milk, hand cream. Foam, that is when gas bubbles disperse in a liquid. So a lot of face wash have that. There are a lot of foamy face wash. Whipped cream, shaving cream is an example. Solid aerosols are also colloids because it contains solid particles dispersed in a gas, such as smoke. And then you have liquid aerosols, which is liquid droplets dispersed in a gas. So that could be like fog, aerosols, sprays, clouds. So this is a table I would like you all to take down in your book. And remember, I was talking about the size. Remember, solution is small. The colloid, well, solution, you don't even see a particle. It's uniform. These two are heterogeneous. You can actually see the particles. So colloid is a bit smaller than suspension, but larger than solution. And suspension will have large particles that floats in the mixture itself. So please take down this diagram as well in your book.
Excuse me, Miss.
Yeah.
This session is recorded.
No, I use a different program because the guest does not record from Teams. Alright, so I'm using something else. Yeah. Thanks for your concern and looking out. I would like to have have two prefects, by the way, for this class, one from 3H, one from 3F. Just to come onto our Teams page, you would recognize we have the separate teams. So that prefect is in charge of just posting a reminder of the homework. Nothing too difficult. If it's just to say like take down the notes, must post it in Google Classroom, or things like that. So you would realize alright, so 3F. You just click on new conversation. I'm giving that prefect a duty to update their class on the homework. It will be the both classes have the same homework. Alright, but just a reminder in each teams. So who in 3F would like to be that prefect? I'm seeing okay, I know I would say this name wrong, so Hari Prasad, would you like to be that prefect for your class?
Yes, miss.
Okay then, so I will put your name in the listing so that they know it is you. How do you pronounce your first name?
Miss, it's Shweta.
Sweta, alright.
Yes, miss.
Sweta Hari Prasad. Alright, so alright, 3H now. I'm seeing someone by the name of Anaya. Anaya, would you like to be that prefect for 3H?
Yes, miss.
Okay, you check your teams regularly and look at the notice and stuff?
Yes, miss, almost all the time.
Right, because the homework prefect must be somebody who is active on Teams. It can't be somebody who don't log in. Alright, so let me put your name. I see you have a long name there, no? I feel I would just put Anaya. What's your surname?
Indar Prasad.
Indar Prasad. Okay. Alright. Not that long. Okay. So now I'm going to post the notes because we can more or less finish. The only thing else for you to take down when I'm sending the note will be this table as well. This is just a comparison. So the only homework is to take down the notes. So it's tables to draw on definitions of the terms: solution, colloid, suspension. Alright, I will discuss this table in class. Feel free to read it through. It's just differences between solution, colloid, and suspension. Right, do you all have any questions at this time?